When we can model variable outcomes with a mathematical model, we can study properties of that variable without even having data obtained from measurements of the variable. I want to demonstrate that in this video. We will see how we can calculate the proportion of individuals or units that we expect to be within a range of scores when the scores can be modeled with a normal distribution. Children's intelligence quotients, commonly known as IQ scores, on the Stanford-Binet IQ test are normally distributed with a mean of 100 and a standard deviation of 15. I have plotted this model. Notice that there is no histogram because we do not have even a single piece of data. Instead, we can look at the model for data obtained from this intelligence test because we know the properties of these data based on both the test developer's calibration of the test and years of data collection. I want to answer a few questions about the proportion of children who will score within specified ranges on this test. If you have learned how to calculate percentile ranks using R, you should be able to answer this first question. What proportion of children are expected to have an IQ below 80? That's just asking for the percentile rank of a score of 80, right? We can answer that using p-norm with the parameters of 80, a mean of 100, and a standard deviation of 15. The answer is 0.09. With this mathematical model and the p-norm function, we can ascertain that 9% of children score below 80 on the Stanford-Binet IQ test. What proportion of children are expected to have an IQ above 110? Now, this question requires a little more thought. We know that we can calculate the proportion of children who will score below 110 with p-norm. Can you think of a clever way to use p-norm to calculate the proportion of children who will score above 110? Here's a hint. The normal curve represents the entire distribution. In other words, it represents 100% of the scores. The percentage 100% written as a proportion is 1. Having given you that hint, I'm going to pause for a moment to see if you can figure out how to use the hint and p-norm to calculate the proportion of children with an IQ score above 110. Time's up. How did you do? If the proportion for the entire distribution is 1, and if p-norm calculates the proportion of the distribution that is below 110, we can subtract this proportion from 1 to obtain the proportion above 110. Let's type in the formula. The answer is that 0.25, or 25% of children, will score above 110. Here's one more challenge question. What proportion of children are expected to have an IQ between 80 and 110? Let's draw the picture. Does this help? Can you suggest a formula? Need a hint? We can calculate the percentile rank for 110, the proportion of children who will score below 110 using p-norm. We can also calculate the percentile rank for 80, the proportion of children who will score below 80 using p-norm. Can you think of a way to use these two pieces of information to answer our question? Let me type the formula. If we calculate the proportion who score below 110, and then subtract from that the proportion who score below 80, we will be left with the proportion that score between 80 and 110. This proportion is about 0.66. That is, 66% of children will score between 80 and 110 on this test. These three questions represent the many questions we can ask about the proportion of data within a specified range of scores. These three formulas, p-norm, 1 minus p-norm, and subtracting a p-norm from another p-norm, are all we need to answer questions about the proportion within any range of scores. The key is knowing that the data can be modeled with the normal distribution and drawing pictures to help figure out what formula you need. If it is not a normal distribution, it's back to the drawing board. Fortunately, the normal distribution is the appropriate model for many naturally occurring variables, as well as variables related to our constructions, such as tests and scales. It is also an important distribution for statistical inference. This means that it will be worth your time to practice with your own questions about the proportion of data in a range to make certain you're comfortable with answering those questions.